All right, hey guys, welcome back. So we're talking about the lock operon, and there's lots of different players in here. This is definitely like a lot more work than the TRP operon. So before we talk about these different players, let's talk about where on the operon it's actually going to bind. So these are all things that are going to bind to the actual DNA. So we got the operator over here. If the time and the conditions are right, if the repressor is active, this is where the repressor would bind to the operator. Then we have the promoter region. CRP is our promoter protein. And it would be binding to the promoter. So the promoter binds to the promoter. Great name. Cool. And then sometimes RNA polymerase will also be binding to the promoter for transcription to happen. And let's talk about what these guys do. Let's go in reverse and start with RNA polymerase. RNA polymerase will bind to the promoter region of the DNA over here. And it will start transcription. Which at this point in the quarter, you guys remember when you first learned about transcription, that seems like forever ago, but you guys know what that is, right? So the DNA, RNA polymerase will bind here, transcribe this DNA to RNA, then that RNA will eventually be converted to protein. RNA polymerase won't always bind to the promoter though. It has some special conditions, right? It'll only do it if it's right. It'll only bind to the promoter if two things happen. This might be a good place to pause and see if you remember what two things have to happen for RNA polymerase to bind. Right, you need to make sure that the repressor, named as the repressor, you can kind of guess it represses the operon. So you need the repressor to be not bound, or else it would be blocking RNA polymerase. And you also need CRP or the promoter to be bound to help it. CRP is kind of like, if it were here, CRP would be like, oh, hey, RNA polymerase, like waving little hands, being like, come over here and bind. So CRP is really important for RNA polymerase to bind there. RNA polymerase won't really bind that much if CRP is not there. So yeah, anyways, the main point is in order for transcription to happen, two things need to happen. The repressor needs to be off and CRP needs to be on. So let's talk about those two things. We got the repressor. And it will bind to the operator. We already covered that. Operator. Unless lactose is present. So just to clarify, lactose inactivates the repressor. Right, so lactose inactivates the repressor. So if lactose is present, it'll turn off the repressor, so the repressor can no longer bind to the operator. That means that transcription could happen, right? That inactive repressor means nothing is getting repressed. Next, we can talk about CAMP. I'm gonna put this in green because CAMP is related to CRP. So the important thing to know about CAMP is it lets us know about glucose. So we have low levels of glucose. That means we have high levels of CAMP, or CAMP. This brings us to CRP, or the promoter. It will only bind to the promoter region if CAMP is present. So it can only do its promoting if we have lots of CAMP. Right, so this kind of breaks the lock operon into two separate things. The whole repressor system, which is controlled by lactose. Right, the repressor system is controlled by lactose. And then we also have the promoter that's saying, okay, RNA polymerase come here, CRP. And CRP is controlled by CAMP, and CAMP is controlled by glucose. So think about the lac operon in two separate ways. There's the lactose, that's controlling the repressor. That's one separate thing. And then the other separate thing is glucose, which is controlling the promoter. Together, the repressor and the promoter control RNA polymerase. Cool, so I hope this helped clarify stuff. Go ahead and try questions 2 and 3 on your own because this should clear up a little bit.